This video is going to go over a couple questions that involve direct substitution. And in this first example, we're going to use it to figure out if n equals -1 is a 0 or not. And before I actually get into the example, I want to cover what a 0 is. And if you look at this parabola, I'm sorry, not parabola, when you look at this polynomial, you could see that I called out a -3, 0, and that's because it's the x-intercept. Well, the x-intercept is the same as the 0, and if you're thinking, well, why is it called a 0? That's because this n value is what happens when our g of n is 0. Okay, so it's our n value when our g of n is equal to 0. In other words, you could think of it as like, x comma y. Our x-intercept here is going to be just our n-intercept, I guess you'd say. So we're just using some different variables. So we want to use direct substitution to figure out if this is a 0 or not. And that just involves evaluating our function. So we're going to use g of -1. And then I plug in -1 for each one of these n values, or n variables. So I've got 2 times -1 cubed plus 5 times -1 plus 3, and I need to simplify this. So I'm going to bring down this 2, and I'm going to work with the exponent first. So -1 cubed is a -1, and then 5 times -1 is -5, and then we've got plus 3 at the end. 2 times -1 is a -2, and then -5 plus 3 is -2, and -2 minus 2 is a -4. So that's the value for g of -1. So when n equals -1, our output is going to be a -4. So was our output 0 at all? Nope, -4. So n equals -1, that is not a 0. If it was a 0, that output value of -4 would have had to actually been a 0. In the second example, we're going to use that same idea, but now we're trying to figure out if n minus 10 is a factor or not. Well, we use the 0 that gets matched up with that factor with direct substitution to figure that out. So if n minus 10 is our factor, set this equal to 0 to figure out what our 0 would be. So add 10 to both sides. That cancels out, and I'm left with n equals 10. That's going to be the 0, and that's going to be our input that we plug into h of n. So we're going to do h of +10, and then we plug in that +10 for each one of our n variables here in our polynomial. So we're going to do 10 cubed minus 4, and then we're going to square 10, and then we're going to subtract 62 times 10, and then add 18 at the end. So 10 cubed is 1,000. I'm going to do a couple steps in one here. 10 squared is 100, times 4 is going to be 400, and then 62 times 10 is going to be -620, and then we're adding 18 at the end. So h of 10 is going to equal -2. So it looks like, let's see, n equals 10 up here. That 0 is not going to be a 0. So it means, well, yeah, I shouldn't even call it a 0. So n equals 10 is not going to be a 0. So that means that the n minus 10, the factor that it came from, is not going to be a factor, because we would have needed this number right here to be equal to 0.